let's look at this. We've got a cruise ship leaving for port at an angle of north 60 east. And then they go for 25 miles. Then we also have that they go straight north for the next 10 miles. So what we're trying to do is we're trying to figure out how far they are from the port. We are going to do this using our vectors. So, first thing we're going to need, oh, here we go. Logan, there you go. All right. So first thing we need to do is it really, really helps to see what the heck is happening here. So if we have a port, I'm going to call this guy port right here. And the ship goes north 60 east. What quadrant is that going to be in? 1. Because we're going to remember that we never eat those soggy waffles. So going from north to the east means it's over here. So that first segment of the trip goes like this. They went 60 degrees this way, and they went for 25 miles. So once they get here, then the boat turns and heads straight north. So if they're going straight north, that's on this picture here, just going up, straight up. So I'm going to draw that in green. So the next thing that they do is once they get here, they head straight north for 10 miles. Hi there. For me? For me?
Yeah, it was Mikey doing.
Oh, yeah, my husband's anniversary tomorrow. Sweet. 16 years? 16 years. Been married. All right. So does everyone see that this is how the ship has moved? Can we get that? Okay. So what we're going to do and what we're trying to figure out is we're trying to figure out how far they are from port and what angle they are. So like their bearing. So we're trying to figure this out. So what we're going to do is we're going to write a vector for the blue piece. We're going to write a vector for the green piece. And when we add them together, that'll give us this vector. Combines them together. So when we're looking at the blue piece, I'm just going to erase the yellow for now. I'll put it back in when we're ready to talk about it. For the blue piece, and when we're talking about vectors in general, we don't actually want the angle off of the north-south axis. We need it off of standard position, off of where angle 0 is on the unit circle. So what angle are we going to use for our vector for the blue piece? We need the angle off of our standard position. This guy. And that's going to be our 30 degrees. So the angle for the vector is based off of standard position, just like off of unit circle. Bearings are just given to us off the north-south because they're being extra. So when we're putting together the vector for the blue piece, that's when we do our magnitude, which is the distance, cosine angle, magnitude, sine angle. So we can straight up write this vector as our distance, that magnitude of 25, cosine of the angle, which we said was that 30. The sine piece of it, or the y piece of that, that's the same magnitude, 25, sine of that 30 degrees. So it's always based off of the angle from our x-axis, that standard position. Our distance is our magnitude. X is the cosine, y is the sine. Questions on that vector? So then we're going to do the same thing with the green one up here, which means, again, I need that angle off of here. What angle is on this green vector? 90. It's this guy right here off of our standard position. So we're going to use our 90 degrees here. So the magnitude on this green one is that 10. So our vector is going to be 10 cosine of 90. 90 degrees, not 9 degrees. There we go. And our 10 sine of 90 degrees. So those are our two vectors. All right, questions on that bit? You could come in through and simplify those right now if you really want to. We're going to kind of simplify as we go and as we get to it. Because what we're trying to do next is we're trying to figure out this distance, and we need to figure out this angle because we want the direction and the distance. So I'm going to call this D because that's the piece we're looking for here. And to get vector D, what we're going to do is we are going to take our two vectors here and we're going to add them together. So that means I need to add the x piece to the x piece, and I need to add the y piece to the y piece. So some of these pieces we have a little bit more information about because we know we're going to have our 25 times cosine of 30. What is cosine of 30? Radical 3 over 2. It's a unit circle value. And then we need to add the x from the other one, so we're going to have 10 times cosine of 90. What is cosine of 90? 0. So we have 25 root 3 plus 10 times 0. Well, 10 times 0 is 0, so we don't have to have it there. I'm just going to leave it right here right now so that we see it where it came from. And then we can do the same thing for the y's. We're going to have our 25 times sine of 30. What is sine of 30? 1/2. Plus our 10 sine of 90. What's sine of 90? 1. It's not pretty, but that's our vector. We could simplify this a little bit and write it as our 25 root 3 over 2 and 25 times 1/2 plus 10 would give us 45 halves or 22.5. Yeah, 22.5. Whether you do it as decimals or fractions doesn't really matter.
Is that or is it both?
This is the x and the y of the orange vector. So this piece matches this guy. I just took these and we simplified it down because this is a hot mess of frozen. There we go. Now it's back. Because this is, it was back. This one's a mess. Gross. This is the same thing, just simplified. I said, well, that's 0, so get rid of it. Multiplied across here. 25 times 1/2 plus 10 gives me 22.5. I didn't touch it. Can we do the iPad? Thank you. I can have the iPad back now. So this gives us our vector for D. That's our standard form vector for D. What we're asked to figure out the direction and the distance, which means I want my magnitude and my angle. So I'm going to give myself a little bit more space. I'm going to switch the page view so that we can actually see what's happening here. So what we're asked to figure out first is the magnitude of vector D. That's what this piece is. This gives us our vector. So to find our magnitude, that's when we use our distance formula 1. The square root of each of these pieces squared. So we're going to take each of these guys and square them and then add them together. So we're going to have our 25 root 3 over 2 squared plus our 22.5 squared. And we're going to type those in the calculator because ew. So we're going to get our magnitude of vector D is going to be type those into the calculator. Cool. Type those in the calculator. What do we get?
31.2.
Yeah, we get 31.22 miles. Which seems about right. If they went 25 miles in one direction and 10 direction in the other, it should be a little bit smaller than the sum of the two. It makes sense. It's a logical answer, which is always a good idea to check. Make sure it makes sense. Don't tell me that they went 500 miles on this kind of stuff. So that's our distance. That's the distance that they traveled. So this is part of our answer. This is how far from port they are. To figure out the direction that they are, we're going to find our angle. We get our angle. So I'm trying to make it so it's not zooming in constantly, but then my handwriting's awful. Arctangent, our inverse tangent, and we do y over x. So we're going to do our 22.5 over that hot mess of an x. Just making that clear. That's our main one. 25 root 3 over 2. And again, we could use the calculators. We could also, take our 22.5 times the 2 and get this to be a less awful fraction. But since we're using the calculator anyway, we can let the calculator do the work. Just be really careful. Because what do we get as our theta here? I'm not going to use blue.
46.1.
Yeah, we should get 46.1 degrees. That means when they were leaving port from standard position, they went 46.1 degrees. That's this angle here. Degrees. So what angle do we use for the bearing? If we wanted to write this as a bearing. Do we use the 46.1? We need this guy. We need its complement for the bearing. So what is the complement here? 43.9. So their location, their direction from where they started, from port, it's as if they went north 43.9 degrees east.
Always take the bearing off the north south.
Say it again.
Always take the bearing off the north south.
The bearing always comes off north-south, every single time. Okay. Oh, we're good. We're doing another one, for sure. Okay, questions on this one though? I really want us to do this airplane one because there's one very much like it on the homework. So let's do the next one as the airplane one. This will be the last one we do. We're not going to get to the third. These just take a while. They just do. So we've got an airplane that had a heading of 228 degrees. And it's going 405 miles an hour. The wind is blowing 25 miles per hour going west. So we're combining two vectors again. So headings we talked about very, very briefly the other day. Headings don't tell us north versus south versus east versus west. Headings are, let me stop this zooming in on what I typed, right? Headings are always based off of north. And they go clockwise. So if we go 228 degrees clockwise, we wind up over here. This is 228 degrees as a heading. So we need to figure out our angle that we use, our theta here. What do we think that's going to be? Because we can take our 228 and subtract 180 to get our little angle down there by the south axis. So our 228 minus the 180. Say it again. Because the angle that we use for our cosine and our sine is always based off of our standard position here. Think about where angle 0 is on our unit circle. It's always coming from there. And normally angles go this way. Headings are just weird because pirates. Pirates use headings and headings are weird. So since this was 228 degrees, I can subtract the 180 to find out that this angle is our 48. Which means that our other angle on there, its complement, the other angle in that quadrant, if I could type things and not do that, there we go, is going to be this guy here would be 42, which means our green angle, our theta, for our airplane here is going to be our 180 plus that 42 to get 222 degrees. So this is the angle we use for our vector. It's obnoxious because we had two different ways of writing the angle here. But it's getting us to the same thing. The heading of 228 and angle 222 are technically coterminal. They're just weirdly worded. So we can write the vector for the plane because we know its speed and we know its angle. Our magnitude is going to be that speed. Everything is looking at speed. So our vector for our airplane, which I'm going to do in blue, is going to be that 405 as our magnitude. Our x is the cosine, and our angle is that 222. The y portion of our vector is very, very similar. We're still going to have that magnitude of our speed. Then we're going to have our sine of angle 222. So this is all of our airplane stuff, which, you know, we're going to do my beautiful airplane. Yay! So then let's get a vector for our wind. Wind. That's how I draw wind. Ooh, windy. Yes, dear. 222 came from this stuff over here. So our heading was 228, which means we could find this piece by taking out the 180. We found the complement here, and then we added a 180 to get to it. Because we're given the heading, which is based off of north, but we need theta, which is based off of angle 0. Can't use the heading. We need to have the angle based off of the x-axis. This one just winds up moderately obnoxiously close. So to do a very, very similar thing for the wind, we need to figure out its angle. So it is going west. So again, remember, we never eat soggy waffles. So if the wind is blowing west, what's its angle? 180. Because it is blowing
Oh, it's just going straight to west?
straight west.
Oh, okay.
It is going west, straight west. So its angle is 180. So we can write its vector as that speed of 25 miles an hour, cosine of 180, and we're going to have our 25 miles an hour, sine of 180. And then we do the exact same stuff we did on the last one. We can find our speed, which is, again, so we had speed. It's our magnitude. The speed is the magnitude. And the heading we get from its angle. So again, I'm going to zoom our page. Just so we have a little bit more space. And then, oh, we are good. We are good. Just watching time because it's weird. So we're going to go ahead and be able to get this combined vector of the airplane plus the wind, because this is a thing that actually does happen. Like airplanes get blown off course by wind. We're going to add those two things together. So our vector, I'm going to call it V for our combined vector. We're going to have our 405 cosine of 222. That does not simplify for us. And we need to add our 25 cosine of 180. What is cosine of 180? -1. So then we're going to have our 25 times -1 that gets added here. So we're going to minus 25. Or plus 25 times -1, if that helps your brain. We do the same thing for the y's. We're going to have our 405 sine of 222 plus 25 times sine of 180. What's sine of 180? 0. So 25 times 0 gives us 0. So plus 0. So that is our combined plane plus wind vector. So to figure out how fast this plane is now going with this wind pushing it, since the plane is headed this way and the wind is coming at it, this is giving us a tailwind, is what that's called. So our plane's going to go a little bit faster. And the way we figure out what their actual speed is we find our magnitude of this vector. So that's going to be super gross looking, because we're going to have our square root. I'm going to change the color on this for a second because I don't like the yellow. It's really difficult to see. I've already used purple. Fine, I'll go black. Boop. So we're going to take our x piece, that 405 cosine of 222 minus 25, that's our x, and we square it. Then we're going to add to that the y piece squared, our 405 sine of 222 degrees squared. And we're going to type it in, and it's going to have those trig functions in there, and it's going to be a thing. It's okay. It's gross, but it's a thing. So type that into the calculator very, very carefully. What do we get as our magnitude?
326.3.
Should be faster. Let me switch it up. Just a parentheses over on this one,
Okay.
because it just squared the sign, I think. Yeah, it just squared the sign there, so it didn't include that 405 in there.
What is the minus 405 cosine 222?
Because we had to, hang on, let me scroll this. There we go. It was our 405 cosine of 222 plus 25 cosine of 180. Cosine of 180 is -1.
Oh, okay.
So it's the 25 times -1. Yeah, no, good question, good question. I would much rather us ask and know and find out than be stuck in confusion land and say, magic happened. Yeah, no, totally fine, totally cool. Just be really, really careful when we're typing this in the calculator, because the calculator will auto put parentheses around these pieces. So we need to make sure we close them off, because it will mess with their order of operations if we don't close our parentheses. Because we should get something around the 424 mile an hour mark. What'd you get? Let me see what happened. You square the sine, not the 405 sine. Okay. So let's close that. And now we've got sine of 222 times 405 225, but it's cosine of 222 that we're subtracting the 25 from. Just like that. Okay. How is it getting worse? All of this plus. And multiply the two pieces together. The plus sign. There we go. So be really, really careful putting this in. It's really, really easy to miss a piece. It's important that we get all of our parentheses closed properly. We want to make sure we're only taking the cosine of the 222. Don't include the minus 25 on there. We're only taking the sine of the 222, and that we have our square outside of this. We should get something that's our 423.9, 424 based on where we round it. But that is the speed of the plane. 423.9 miles per hour. That's their speed. To find its heading, we need the angle, or to find its bearing. We are still good. So to find our angle, that's when we do our inverse tangent. And it's gonna look super gross. Oops, sorry. Our theta comes from our arctangent of our fraction that has our y, that 405 sine of 222, over the x, 405 cosine 222 minus 25. Again, remember to close this set of parentheses here, just like we do up here. So our inverse tangent is going to give us the angle. So try and type that and see what angle you get. Some of the things I have back, my tile's getting a little obnoxious.
Is it cosine 222, like 222 in parentheses and then minus 25?
And then minus 25, correct.
I got 39.
What do we get?
39.7.
39.7. Yep, that's what I got as well. So that gives us the angle 39.7. What quadrant is angle 39.7 in? It's an angle 1. Is this the right direction for our plane to be going? No.
It's the opposite.
Mm-hmm. So what is the actual angle that it's going to be? Because this is our 39.7.
Wait, 4. Is it minus 180 or minus
219 or something.
I was going to say, if we want to get all the way over here, we need to add 180.
Oh, add 180.
Mm-hmm. Yep, so that gives us that this angle here, 219.7, is that our heading? It's not. This is the angle here.
North axis?
Pirates, chaos, start at north, then go round.
So minus 360?
I was going to say, I tend to do it kind of this way. This guy is going to be the same angle as this one. Our 39.7 is this guy. So we have our 180 plus the complement of 39.7.
Oh.
So we'll need 180 plus the complement of 39.7. So we'll have our
230?
and I don't actually have it written down. Yes. So our heading their heading would be the 230.3 degrees. Headings are chaos. They come off of north and go to the right because pirates are just sure that they're right. But headings mostly used by ships or planes and things like this. Okay. Questions on this one?
What do you have to get the heading?
What's up?
What do you have to get the heading?
To get the heading, we need to find this green one. Heading comes off of north and goes clockwise. So I took my angle that we got from tangent. That gave us this 39.7 over here. So we need our 180 plus the complement of 39.7. All right. So I'm going to pass back some things I have. This is honestly my file's getting a little obnoxious. So make sure you're checking these things, that they're in the grade book correctly, because things happen, mistakes happen. See how big this file is, that happens. We're not gonna do any more than this, like we're really close to the end of the period, because we're until 47 in here, which is in about 3 minutes. So, I'm gonna pass these up, we're gonna switch to the master page, just so you see it. And okay. So, boop, boop, boop. There we go.
Jeez. You really want to start with the break?
I do. Have a great spring break. Make great choices. Very restful. Come back rest refreshed. Because when we get back, it's gonna go fast. Yes, dear.
That is, I was gonna say, that is the angle. I needed the coast.